Okay, today we are going to, before I proceed to the last blackboard testing techniques, I would like to, in case some of you still have some confusion regarding about how to combine boundary value for multiple input variables, okay, to form the boundary value for the whole program before you design test cases. Okay, I would like to highlight one point for you to think about that may make you clearer. Okay, so yesterday we said that for boundary values, we identified boundary value for each input variable separately. After that, we combine them together. We take all the combination, but with some restriction. Okay, for those cases involve invalid boundary value, we only allow one input variable to have invalid boundary value. Okay, I want to show you a difference from this example. Okay, hopefully you can spend a few minutes to think and you will be clearer. Okay, take for example, here I have 4 boundary value for money income, 2 input variable, and 4 boundary value for number of houses. Okay, if you simply just take all the combinations, that means how many combinations? 4 times 4, 16, right? 16, okay? And with the restriction that for cases involve invalid boundary value, we only allow one input variable to have invalid boundary value. So we only have 12 cases. You can see from here. We do not have 16 cases. If we simply just take all the combination without any restriction, then we will have 16 cases. But here, we only have 12 cases. So if you still do not understand, you try to think over and see the differences. You will be able to understand. All right, so we proceed forward. Okay, today I'm going to proceed to the last functional testing techniques, that is cause-effect testing, decision table-based testing. Okay, so every testing technique has its own objective, has its own principle and philosophy. What is the principle of cause-effect testing? Okay, decision table-based testing is also called cause-effect testing. Okay, so what is the principle of cause-effect testing? The principle is that this testing method is to explore all the combination of conditions, all the combination of input conditions, to ensure that we have tested every value for the combination of conditions, the combination of all the conditions. Okay, so this method is very suitable for those systems which are very much business rule, based on business rule. That means the system based on rule, something like when it's a regular customers, if he purchase up to certain amount, the company will give 5% discount, such thing. Okay, this kind of business rule. If the system is very much on such, if the system is very much business rule oriented, then this testing method will be very useful. Okay, now we learn. Okay, now we learn how to apply this testing technique to test each value of combination of condition, of input condition. Okay, so the first thing we have to do is we extract out, that is understood, all the blackboard testing techniques based on requirement, based on specification. So we based on specification, based on requirement, we identify all the basic input conditions and output actions. Okay, output action, it means the way the program compute, the way the program supposed to decide. Okay? How about, is there any meaning of this particular word, basic input condition? Okay, why I don't just put input condition? Yes, there is a meaning of it. Okay, the basic input conditions means you extract from the specification all the single condition. You should not extract conditions such as x greater than 2 and y less than 4. You should not extract such condition. This is not a basic condition. This is a compound condition. Basic condition means that you examine the specification and you extract single input condition. So if you have such thing, x greater than 2 and y less than 4, you should extract x greater than 2 and y less than 4 as two separate basic conditions separately. Okay, you should not have a logical connector in between. Okay, so this is the meaning of basic input condition. So every all the conditions we extract out will be single condition. Okay, it should not be a compound condition. And we construct a decision table. Okay, so we use a decision table as a tool to help us to explore all the combination of condition values. Okay, so we construct in the decision table there are two regions, condition and actions. Okay, so before we move further, I would like to show you the format of decision table. Just take a quick look of this decision table. We have two regions, condition and actions. Okay, so we extract out from the specifications, the requirement, all the basic input condition, and we put them down here under the condition region. This is the condition region, and this is the action region. So all the actions will be listed down here. So then after that we can start to form the complete decision table. Okay? So each column here is to show a combination of condition value, a value for the combination of all the conditions. Okay, so we extract out two things and we start to construct a decision table. After that, we will add a row, add a column to show each possible value of combination of conditions. Okay, so and we call each column a rule. Later I will show you through the example. Okay, this is a rough idea of how to apply cause-effect testing. Okay, now we look at a simple example. This is the specifications. This is a simple specification. So we analyze this simple specification and apply cause-effect testing. This specification says that this is a online trading, stock trading program. The input to the program is the stock name, the company name, quantity to buy, and available fund in the accounts. Okay, so these are the three pieces of input to the program, and the program just perform a very simple function to decide based on these three input to decide whether to accept the order from the customer to buy or not to buy or to reject. Not to buy means reject. Okay, under what condition it will be approved? This is under if the order satisfy all these conditions. If the three pieces of input enter satisfy all these conditions, then the buy order will be approved. Stock name must be a valid listed company, firstly. Okay, and quantity to buy must be in the multiple of 1,000. That means you cannot buy 500. You cannot buy 20 share. When you buy, you must buy 1,000, 2,000, 3,000, etc. Available fund, that means the available fund must be sufficient to cover the cost as well as the charges involved. Okay, so these are the conditions to satisfy before the program decide whether to buy or not to buy. If it's satisfied, the program will approve the buy order. Okay, this is the specification. So, for applying cost-effect testing, the first thing you extract from the specification all the basic input conditions. So, what are the basic input conditions? In this case, there are 3 basic input conditions. Stock name must be valid. Okay, quantity to buy must be in the multiple of thousands. Available fund must be sufficient. So, these are the 3 basic input conditions. So, we extract it out and put them in the decision table as such. Stock name, okay, must be valid. Okay, this is the way I show this condition. Valid stock, whether it's valid or not. If valid, then it's yes. If not valid, it's no. Okay, you can put true or false also. There's no difference. So this condition have 2 values, either valid or that means either yes or no, or either true or false. If you use true or false, then valid quantity, that means in the multiple of thousands. Okay, then the third condition is whether fund is sufficient. So I extract from the specification these 3 basic input conditions and I put them in the decision table. Okay, this is the way to do. Then after that, okay, we have to extract the output action also. What are the output actions? This program just perform a very simple actions, okay, to decide whether to buy or not to buy. So output action is buy, whether to buy or not. Okay, so likewise, I show them in the decision table in the last region, action part. Okay, so by doing so, I have the framework for the decision table. Okay, in this way, now I can start to show each combination of conditions value, each combination of all the conditions value. Okay, so in this case, the stock name can be valid or invalid. Valid, okay? So this condition have 2 values, this condition also have 2 values, and this condition also have 2 values. So how many combination of condition value? And furthermore, all these are independent. Independent means if the stock name is valid, quantity, when the user enters a valid stock name, he may enter a valid quantity, or he may also enter an invalid quantity. So these 2 conditions won't affect each other. Anyway, all the conditions here won't affect each other. So they are totally independent conditions. So actually, straight away, I can work out the total number of possible combination of condition values. Okay, 2 times 2 times 2. So it should be 8 combinations because all these are independent conditions. So then I use a decision table to exploit, to make sure that the purpose of using decision table is to ensure it's firstly for presentation, easy to show, okay, easy to read. Secondly, to help you to ensure that you have covered each possible combination of condition values. You have covered all the possible combination of condition values. So there are 2 purposes for using the decision table. Okay? So here I start from all no. You have to do it systematically. Either you start from all yes here or start from all no. When you start from all yes, the last row, last column must be all no. Okay? If you start from all no, the last one must be all yes. Okay? You do it systematically. So firstly I start from all no. Okay, this is possible when the stock name is not valid, quantity could be not valid also, sufficient fund, okay, may not have sufficient fund also. So this is a possible combination of condition value. I list them down as 1 column, okay. Then after I go through the all no case, the next possible combination of condition value is with 1 yes, 2 no, and 1 yes. That one of them had yes. Okay? One of them had yes, there are 3 cases. It can be this one yes, it can be this one, it can be this. So there are 3 cases for 1 yes, because we have 3 conditions here. Okay? After you have go through all 1 yes, then you consider 2 yes. Okay? For 2 yes, again there are 3 cases. Can be this 2 yes, can be the first and the last, can be the first and the second yes. Okay? We have gone through 1 yes, 2 yes. The last one is all yes. Okay? That is also possible. So after you, from all no to reach until all yes, that means you will cover all the combination of condition value. Alright? So after you have shown, you have completed all the column, then we go back to the specification to complete the value for the output action. In this case, the value for the output action is very simple. Decide to buy or not to buy. The first one, invalid, not to buy, not to buy, not to buy. Only the last one supposed to buy, yes. Okay, by doing so, we have completed the construction of decision table. Okay, once you have finished the construction of decision table, the next thing to do is to design a test case for each column, that means for each rule. Over here, we call a column a rule. It's just a name. Okay? Column 1, column 2, column 8. So we call it rule 1, rule 2, rule 8. Okay? So for each rule, we design a test case. For each rule, we design a test case to test it. Okay, this is for the first rule. So very simple. Very simple to design a test case for each rule. In order for the first rule, that means you must design a test case with invalid stock name, with invalid quantity, with insufficient fund, because all no, to satisfy all these conditions. Okay? So we have the first rule, stock name asterisk definitely is invalid quantity 0.2 and available fund nothing. So surely it will be rejected. So the buy order is no. For the last rule, all must be yes. That means must be a valid stock, must be valid quantity, it must have sufficient funds. So we put stock name, DBS, quantity 1,000, available fund, okay, 100,000. So it's sufficient. So the output action, the program should approve it to be yes. So by doing so, we design 8 rules, we design 8 test cases. Okay, now we come to, okay, this is so much on decision table based testing. Okay, earlier on I told you that here we have 3 conditions. Since each condition has 2 possible values, so the total number of combination of condition value is 2 times 2 times 2. Okay, that is 8. Okay, so you can compute it actually, but it does not mean that you can compute it for all cases. Okay, here we can compute it is because all the 3 conditions are fully independent. Okay. They do not depend on each other. That means if it's valid stock, the quantity can be invalid, can also be valid. Both possible. So they are totally independent. That's why we can compute it. But in general, this may not be true. And that is one of the reasons that's why we need to use decision table to help us to ensure that we have covered all the possible conditions, combination of condition value. Okay, you look at this case. If you have this set of basic conditions, x greater than 5, y, x less than or equal to 5, y greater than, okay, if you have this set of conditions, then we only have 4 possible combination of condition values. We do not have 16. According to the all combination means 2 times, because every condition can have 2 values, yes or no, or true or false. 2 times 2 times 2 times 2, 16. Okay, so they are synthetically there are 16 combinations. Okay, but we only have 4 possible combination of condition value. We cannot compute it. Why? Because over here, quite a lot of conditions depend on each other. When x greater than 5 is true, right? X less than or equal to 5 definitely will be false. It cannot be true. There's no way for x less than or equal to 5 to be true when x greater than 5 is true. Okay, so they are interdependent. They are interdependent. So you cannot compute as what I did for the earlier example. Okay, so in this case, if you use a decision table, you start from all yes, let's say yes, yes, yes. Okay, you will find that it's not possible. All yes, 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 yes. It's not possible because when this one is true, when x greater than 5 is true, x less than or equal to 5 is definitely no. Okay, when this one yes, this one definitely no. So those impossible combination of condition value you should not include as a column in your decision table. Should be eliminated. Okay, so this is an important point. I hope you will bear in mind. Okay, the method we have just learned for applying cause-effect testing. Firstly, we extract all the basic conditions from the specification and list them down in the decision table. Okay. Need not to consider whether they are dependent or not. Okay. And we put all the output action. Okay. This is a general method, and this will definitely be correct. This will definitely be correct. Okay. But your decision table may be bigger, may be quite big for some cases, especially for complex cases. That means the general method, by listing down all the basic conditions, extract from the specification, and simply just include them in the decision table, and from there you construct the decision table, is fine. You will work for all cases. But one disadvantage is that if you always do that, you may end up with too many basic conditions in the decision table, and your decision table may be quite big. Okay? The last few slides will show you how to reduce the condition in the decision table to be minimum. Reduce it to be minimum. That means when you have interdependent conditions, some of the conditions can be removed, need not to be included in the decision table. So the last few slides show you how to do that. Okay, so if you want your decision table to have if you want the conditions in your decision table to be reduced to the minimum, then you no longer can just simply include all of them in the table. You will have to include one by one. Okay, firstly, we extract out all the basic input conditions from the specification. We extract it out and write them down somewhere. But after that, we do not simply just include them in the decision table. We include them one by one. Okay? So only if the condition, every time we consider one, okay, the order doesn't matter. Okay, so we put them somewhere, then we consider all the conditions one by one until we have processed all the conditions. Okay, so we process the first one first. When we process the first one, Okay? Since we do not have any condition in the decision table, definitely you will satisfy this condition. Definitely so you will simply just include them, include in the decision table. The first one will always be included. Okay. By doing so, you will eliminate some of the condition extracted from the specification. Okay. The detail I'm going to show you through the example here. Okay. We are going to use this one as the example to show you. Okay. Assuming that from the specification we extract this set of condition. So now we want to reduce this set of condition to the minimum. Okay, to the minimum. So we consider one by one. So assuming that we list them now in this order, so we will consider this one first. X greater than 5. So when you consider x greater than 5, since there is no condition in the decision table yet, nothing there yet, so certainly there's no way to derive x, the value of x greater than 5 from any conditions that has been included in the decision table, since there's nothing there, empty at first. So there's no way to find condition in the decision table to derive the value of this one. Okay? So we will simply just include it. The first one will always be included, by the way. Then after that we proceed to consider this one. X less than or equal to 5. Okay, when we consider x less than or equal to 5, it's a different thing already now. Okay, we have already one condition in the decision table, that is x greater than 5. Okay? And you can easily check that for x, when x greater than 5 is true, the condition that has been included in the decision table, now we have x greater than 5 has already been included in the decision table. Okay? So, and for every value of x greater than 5, you can see that we can uniquely determine the value for x less than or equal to 5. Okay? When x greater than 5 is true, x less than or equal to 5 is definitely false. When x greater than 5 is false, x less than or equal to 5 is definitely false. It's definitely true. Okay? So for every value of some condition in the decision table, we can compute a unique value for the condition we are considering now. For every value of combination of conditions that have been included in the decision table, we can compute a unique value for the condition we are considering. Okay, so that means this condition can be derived from some condition that have been included in the decision table. So we will not include this one. We will throw away this one. Okay, so that is the second condition we consider. So by now we have already considered this one. Now we proceed to consider this one. Okay, the third one. When you consider the third one, you will find that. So when we consider the third one, we still have one condition in the decision table only, x greater than 5. You will find that when x greater than 5 is true, okay, when x greater than 5 is true, that means when the condition in the decision table is true, y greater than 2 can be true or can be false. There's no way to calculate. There's no way to determine whether y greater than 2 is true or false. Okay, so that means this condition is not derivable from any condition in the decision table. It's not derivable. So we have to include y greater than 2 in the table. Okay, so after you check the third one, we proceed to check the last one, y less than or equal to 2. Okay, when you check y less than or equal to 2, then you will find that for every value of y greater than 2, okay, that has been, now y greater than 2 is in the decision table already. So for every value of y greater than 2 is true, we can, for every value of y greater than 2, we can determine a unique value for y less than or equal to 2, okay, as such. That means y less than or equal to 2 is derivable from some condition in the decision table. Okay, so we will throw it away. We will throw y, we will eliminate y less than or equal to 2. Okay, so at the end we only include 2 conditions. Instead of 4 conditions, we only include 2 conditions. Okay. Okay, so that means this set of conditions can be reduced to 2. And the answer is not unique. Okay. Depending on which one you check first. Okay, I check from x greater than 5 to y less than or equal to 2. I check the condition in this sequence. If you check the condition in other sequence, you may end up with a different set of minimum conditions. Okay, but you will also have 2 only. You will, okay, so to take note of this part. Okay, that's all for this unit. Now we proceed to Unit 8, the last unit. Okay, the objective of this unit is to learn the main objective of this unit is to learn the 3 basic structural testing techniques. But before we learn the basic structural testing techniques, we have to learn a tool. We have to learn a tool to model the logic of code. Okay, because structural testing techniques design test cases based on code, and our main objective is to learn the structural testing techniques. But before we learn the structural testing techniques, we have to learn a tool to model the logic of code. That is the control flow graph. Okay, so firstly we have to learn control flow graph first. After that, I will introduce you 3 basic structural testing techniques. Again, we are going to learn 3, and these 3 techniques are the more fundamental ones. And I'm going to introduce you basic structural coverage analysis. Okay, this is a measurement, in fact, a measurement to measure how good is a test suite. A test suite means a set of test cases. And towards the end, we will briefly go through the overall testing. We will briefly go through the approaches for overall testing. Okay, firstly we have to learn control flow graph, and this is very important. Control flow graph is very important in order for you to apply structural testing techniques. Without control flow graph, okay, there's no way for you to apply structural testing techniques. Control flow graph, okay. In short, we call it CFG. The objective of control flow graph is to model the execution flow between statements in code. That is the purpose. Okay, in order to systematically analyze a piece of code, okay, we have to construct control flow graph. A control flow graph is formed by nodes and edges. Okay, a control flow graph is very simple. It's formed by nodes and edges. As such, this is a control flow graph, okay, formed by nodes and edges. These are the nodes. 1, 2, 3, 4, 5. These are the edges. Arrow, all the arrow, okay, are the edges. edges are to show execution flow. Okay, what does each node represent? We have already seen the structure of a control program. Inside there's a lot of nodes. What does each node represent? Okay, a node in a control program is to represent a basic block. Okay, now what is a basic block? Okay. A basic block is a sequence of statements. That is always executed from the first statement to the last statement sequentially during program execution without any skipping, without any jumping. So a basic block is a sequence of statements in a piece of code that always execute from the first statement by statement until the last statement without any jumping from one to another. Okay, sequentially execute it. Only the kind of sequence in the code we can represent it as a node, and we call the kind of sequence as a basic block. As I told you, each edge in a control program is to show execution flow between basic blocks. By showing the execution flow between basic blocks, the execution flow between statements also implied. Okay, in a control program, a node that have more than one outgoing edges is a decision node. This is an important definition also, because later when you learn structure testing techniques, you have to use this definition, decision nodes. And nodes, they have more than one outgoing edges. Okay? Those spatial nodes, they have more than one outgoing edges, we call them as decision nodes. Okay, in this control program, let's say, how many decision nodes? Just now I say, in a control program, and nodes, they have more than one outgoing edges. Outgoing edges is called a decision node. So in this graph, how many decision? Two decision nodes here. 2 and 3. Only 2 decision nodes. This one have 2 outgoing edges, more than one. 1, 2 outgoing. Okay? And this one also have 2 outgoing edges. So this also decision node. This also decision node. The first one is not, only 1 outgoing edge. Okay? This one is also not a decision node because only 1 outgoing edge, although they have 2 incoming edge. Okay? So in this control program, there are only 2 decision nodes. Okay, sometimes we may use, in general, we will represent all nodes regardless of whether it is a decision node or not a decision node. We will represent it as a circle. But sometimes we may want to differentiate decision node from other nodes by representing it as a diamond. That is possible also. So we can represent decision nodes as a diamond. In case that you are not too familiar with code, okay, in case some of you are maybe quite unfamiliar with code, okay, this slide is to show you how a program, how a piece of code is executed, because later when we identify basic block, we need to have this knowledge. Okay, so for this piece of code, firstly, you will execute this statement. Okay, after you execute this statement, you will execute the second statement. So that's why I draw an arrow here. All the arrows show execution flow. After you execute the second statement, you will go to the third statement. After you execute the statement, you will go to the fourth statement, etc. Okay? So when you execute the fourth statement, it's no longer sequential. Okay? So it depends on whether this condition is satisfied. If it's satisfied, If it's satisfied, it will flow to here. You will execute this statement. If it's not satisfied, you will go to the statement immediately after the loop. The loop is here, while and while. Okay? So there are two possible execution flow. After execute this statement, one is here, another one is here. All right? So this piece of this slide is to give you some basic understanding of execution flow between statements when a piece of code is executed. Okay, for if statements, again, is not strictly sequential. After execute this statement, if it's satisfied, it will come here, right? If it's not satisfied, it will go here. So there are two possible execution flow. Okay, so if you are not very familiar with code, I suggest that you go through this slide carefully yourself. Okay, now we come to construction of control flow graph. Firstly, you will have to identify basic block. These are some general basic structure for a control flow graph. Sequence, strict line, one after another. Okay, then we have the if structure, selection structure. After this nodes, it may flow to here. The execution may flow to here also. Okay, at the end it merges. For while looping, okay, you will check the condition. If the condition is satisfied, you will flow through here. If it's not satisfied, you will come here. There are some more structure, but those code you are going to see, you will not involve these two. So maybe we skip these two. Yeah, we skip these two. The last two, you can take note of it. Okay, now the important step you have to do when you want to construct a control flow graph is to identify basic block, right? Because without identifying basic block, there's no way for you to construct control flow graph. And the general principle is that a basic block is a sequence of statements that always execute from the first statement, exit from the last statement, statement by statement without any jumping, okay? And in order to help you, I have the rule here. In fact, I have two sets of rules. The first one can be applied to any program, any kind of program. Okay, we skip it since we are not going to see, we have this type of code. All the code you will see, okay, you are going to have, you may have in your tutorial or exam, or you will be structured code. So we are going to base on the rule under the third point, that's all. Okay? Skip the first one. Skip the first one. So how to divide, when it's given a piece of code, how to divide the piece of code into basic block? Okay, you apply this rule, very simple. Cut out the while clause to form a basic block by itself. Okay, I have the cutting here, cut out the while clause. Cut out, it means cut here, cut it out, it means cut here, cut before and cut after the while, right? So by doing this cutting, okay, so the first rule says that you cut out the while clause. That means do a cutting here, do a cutting. Okay, the second rule says cut at the end of cut at the end of end if, cut at the end of else, cut at the end of end if. Okay, cut at the end of. Okay. Cut, to be more precise, maybe you add in one more word here. Cut at the end of if clause. Okay. Cut at the end of if clause. Cut at the end of if clause. Add the word clause here. C-L-A-U-S-E. Cut at the end of if clause. Cut at the end of else. Cut at the end of end if. Cut at the end of end while. Okay. Okay, I'm going to show you how to. So earlier, by applying the first rule, we already have this cutting. The second rule says cut at the end of if clause, cut it here. This is if clause, cut it here. Cut at the end of else is here, we cut it here. Cut at the end of end if, cut it here. Cut at the end of end while, we cut it here. Okay? So do all this cutting. By doing all this cutting, you will cut the piece of code by applying the two rules. Okay? So I have already shown you how to apply the second rule. By applying the two rules, you will cut the piece of code into basic block. Okay? So you will cut in such a way. That means the first block is here. First sequence of statement is here, first block. The second one is here, third one is here, fourth is here, fifth is here, sixth, seventh. Okay? So you will cut it into 7 blocks. And we write a number to represent each block. The first block contains 3 statements from here. The second block contains only 1 statement. The third block contains 3 statements. Then we draw a notch in the control program to represent each basic block. So that's why we have 7 blocks here. That's why we have 7 nodes. Then after that, you draw arrow to show the execution flow between basic block. After the first one, certainly you will go 2. Can you give me a few more minutes to complete this one? After 1, you go to 2. After 2, after execute 2, you will go to 3 or go to 7. Because depending on whether the condition is satisfied. So we draw all the arrow to show. After execute 3, you will go to 4 or go to 5, depending on whether condition is satisfied. We do it accordingly. Okay, another very important point to highlight is that just now I said that a basic block is a sequence of statements that always execute from the first statement to the last statement, statement by statement, without any jumping. Okay, you can see that all this sequence satisfy the property I have read out just now. Always execute from first one, statement by statement until last statement without any jumping. Okay? If I combine, let's say if I combine this statement with the first 3, if I combine the first sequence with the second sequence together, it no longer satisfies the property I have read out. Okay? Always execute from first statement and exit from the last statement, statement by statement without any jumping. Okay? Because when I combine them together, when they execute the first time, you will exit from here. The second time, after that, at the end of the loop, you will come back to here. You will enter from here during program execution, because depending on the condition, if after finish the loop, you will come back to here to check, okay, whether the condition is satisfied. So you will enter from here. You can enter from here. It no longer always execute from the first statement to the last statement. Statement by statement. Okay. So I suggest that if you still do not understand, you go back and try to combine. Instead of having this sequence I have just cut for you, you try to combine, try to build bigger sequence and see whether it satisfies the property of a basic block. Okay. By doing so, it might help you to understand better. Okay, so today we stop here.